Welcome to this video on XYZ Analysis for Dynamics 365 for Finance and Operations. First, what is XYZ Analysis? If you're selling goods, you're thinking about the variance of the demand, and XYZ Analysis gives you a kind of categorization of your products in 3 different categories: X products selling regularly, Y products with some variance, and Z products with a very high variance on demand. Let's make an example. Let's say you are monitoring your demand on a monthly basis. So January, February till December. And for a first example, let's say you are selling toilet paper. Toilet paper has no variance at all. All through the year, people have to do their poops and they're buying toilet paper. So the demand for toilet paper would look like this. You're selling 100 pallets, pieces, whatever. In January, you're selling 100 pieces in February, and throughout the year, you're selling the same amount of toilet paper each month. Now let's think about another example. Let's say you are selling tires for cars. Then your demand would look like this. You have very low in January, very low demand in February. Now when it's getting warmer, people are start thinking about buying new tires for their cars, buying summer tires. So maybe in March you sell 20, in April 30, in May 20, and through the summertime you don't sell so much. And starting with end of summer and beginning of autumn, your demand is increasing again. So we have 20, 30, and with winter, demand is falling. And let's make a third example. Let's say you are selling firework. So maybe you are selling nothing in January, nothing in February, nothing in March, nothing in April. But in May, when it's getting nicer, people start to have marriage and celebrating, so you're selling some firework in May, nothing in June, nothing in July. But with end of summer, there are a lot of events and your demand is increasing here. In September, you don't sell anything. October, November, and in December, with the new year, you have a very high demand. Now let's have a look at the demand of this product. Let's make a line chart here. And as you can see, the blue line here is toilet paper. The demand is very, very stable. The orange line are car tires with some peaks here. And the gray line is firework with some peaks and some month without selling anything. So this is a very, very unstable with a high variance product. So in order to categorize these products based on the data you have in your, let's say, ERP system, of course, there is a metric called the Variance Coefficient, and this is calculated based on the mean and the standard deviation. Let's have a look. So first we need the mean. The mean is the sum divided by the number of observations. In our cases, we have 12 months, so 12 observations, and not very surprising, the mean here is 100. The mean for tires is 16.6 and the mean for firework is 15. Now we need the standard deviation. The standard deviation gives you an idea about the variance in your data. And not very surprising, the standard deviation here for toilet paper is 0. The standard deviation for tires is 7.4, and of course the standard deviation for fireworks, which has a very high variance in sales, is about 30. So this here is the mean, the standard deviation, and the coefficient is defined as the standard deviation divided by the mean. This gives you some calculated values here, and depending on the books and literature you're reading, there are some values that are used to categorize these products. So for our example, we can say if this coefficient is smaller than, let's say, 0.25, it's an X product. If it is smaller than 0.7, it's a Y product, and else it's a Z product. So in our example, based on the data we have recorded and based on this calculation, we would say toilet paper is an X product, tires are a Y product, and firework is a Z product. Now let's talk about another topic. In this example, we have used the aggregated amount here based on the months. However, this might not be the best idea, depending on your product. So for example, you are selling ice cream, and you are selling, let's say, ice cream only in summertime, so in June, July, and August. And you're selling 100 pieces in June, 100 pieces in July, and 100 pieces in August. So the demand mean would be 100, standard deviation would be 0, coefficient would be 0, and this would clearly be an X product. However, if you are selling ice cream, you would like to break this down maybe on a weekly basis. So let's say we have week 1, week 2, and just to simplify this here, we assume each month is only 4 weeks, and you're selling here the first week 10, in the second week 20, in the third week 50, and in the fourth week 20 again. This would be 100 in 1 month. The same in the second month and the third. So these 4 down here are August, and these 4 here up would be June. So now if we calculate our coefficient again, so first let's make the mean. Next, the standard deviation. And the coefficient is deviation divided by the mean. This would say it's 0.6, and here would say, in this case, this is a y product. So what is true here? It's the same product, only the time frame is here different. Well, let's say if you are using ice cream as example, you would like to go for this here, because you are interested on the variance in a very short time, because you cannot store ice cream for a very long time, and of course you cannot refrigerate it. So if the demand changes within the time where the product has to be sold, you would go for this here. If you're selling, like in the last example, toilet paper or winter tires or summer tires, you would like to go on a monthly basis. So there is no simple answer what would be the best time frame. Depending on your product, you should decide by your own if you would go on a very small basis, maybe a weekly basis, maybe a daily basis, to identify the variance, or if you want to go on, let's say, a monthly basis. Before we start with Power BI, there's one important topic that we should consider. It may be obvious, but if we go to aggregate the demand based on dynamics data, we have to make sure that we also take into account time periods where we didn't sell anything. So let's make an example. Let's say again we are grouping by month: January, February, March, April, and May, and so on. And when we run a query against Dynamics 365, we may get a demand for, let's say, 100 pieces here, 100 pieces here, 100 pieces here. We don't get any data for April, and 100 for May. So now if we would calculate the mean here, which is the sum of these values divided by the number of observations, if we only count the records that we get back, this would be 4, but not correct. Because we have to consider that we have 1 month where we didn't sell anything, so the correct mean would be the sum divided by the number of observations we have, and in this case we have 5 observations, so the correct mean would be 80 here. And this takes into account that there are some data and some rows without data, and we have to make sure in Power BI that we create a data set that presents also records with 0 quantity or 0 demand. Like said, this is very obvious, but we have to take this into account in the Power BI example. Let's go in Power BI. And I'm using here the OData feed from this demo virtual machine. So I'm going to open the URL here. And in Power BI, I'm going to my OData feed, add data, and I'm going to use the sales invoice lines. I'm going to edit the query and transform the data. I don't need data area, the invoice number, sequence number. I will keep the invoice date for now. Going to delete site, dimension, batch, discount, product configuration, tax amount, status, size, currency, product number, color, style, shipment, sales price, warehouse, sales unit, charge amount. I keep the invoiced quantity and I'm going to delete the line amount. Next, I'm going to add two columns, one for year and one for month. This can be done using date.year based on the invoice date. And date.month from the invoice date. Now I can delete the invoice date. And I'm going to group this data by product name, year, month, and sum up the quantity. So I'm going to transform product name, year, month, and make a group by and call the new column quantity. Segregation is sum from the invoiced quantity. Okay, and I am going to call this demand. Next, I'm going to create a table that contains a combination of every month for every product. So the basis for this is a calendar table. In a sophisticated use case, you would like to use code, but I'm going to type it in here because we only use 1 year. So it's 2015. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So very simple. This is the year column, the month column, and I call this calendar. And now I'm going to expand every record from year and month for each product. This can be done by adding an additional column. And I call it product name, and it contains a distinct list of products from the demand table. Product name. Now you see we have a record 2015 January for all the products, 2015 February for all the products, and so on. And in the next step, we're going to merge the demand and the calendar table. So I'm creating here a new result set. I'm starting with the calendar and I'm merging with the demand. And I'm merging year, month, product name with year, month, product name, and use a left outer join. So we have all entries from the calendar table, and if there is a demand in this combination of year and month for this product, we will have the value here, otherwise at null. So let's start the merge. And we are interested in the quantity. I'm going to replace values, null if any, with 0. Okay. And change the name to XYZ. Now we can close and apply. Now let's calculate the coefficient. So I'm going to XYZ and create a new measure. I call it VAR for variance coefficient, and this is to divide the standard deviation of the quantity in XYZ by the mean of the quantity in XYZ. Let's have a look at the data. So we have here a product and the coefficient, and it looks like it's almost the same for every product. That's okay. And create another measure for the categorization. So if the coefficient is smaller than 0.25, it's X, else if the coefficient is smaller than 0.7, it's Y, otherwise Z. So looks like in this demo data for this company, we have only products categorized as X products.